Variable stars, those celestial objects whose brightness fluctuates over time, have played a pivotal role in our understanding of stellar physics, galactic structures, and even the fundamental nature of the universe itself. The history of variable star research spans over 4 centuries, evolving from isolated observations of oddities in the night sky to sophisticated international collaborative efforts involving both amateur and professional astronomers. This research has not only expanded our catalog from a handful of stars to millions of documented variables, but has also revolutionized our understanding of stellar evolution, provided crucial distance markers for cosmic cartography, and challenged ancient philosophical notions about the immutability of the heavens. The story of variable star research begins in the late 16th century, challenging the prevailing Aristotelian view that the celestial realm was perfect and unchanging. The first recorded observation came in 1596 when David Fabricius noted a star in the constellation Cetus that later seemed to disappear. This star, initially thought to be a nova, was rediscovered in 1638 when Johannes Holwarda observed that it pulsated in a regular 11-month cycle. This star, Omicron Ceti, would later be renamed Mira, meaning wonderful, and would become the prototype for an entire class of long-period variable stars. This discovery was revolutionary, as it provided concrete evidence that stars were not eternal and unchanging, as Aristotle and other ancient philosophers had taught, thereby contributing significantly to the astronomical revolution of the 16th and early 17th centuries. The second variable star discovery came in 1669, when Italian astronomer Geminiano Montanari observed the periodic dimming of Algol in the constellation Perseus. However, the correct explanation for Algol's variability, that it was an eclipsing binary system, would not come until 1784, when English astronomer John Goodricke provided the accurate interpretation of its regular pattern of brightness changes. The third variable star, Chi Cygni, was identified in 1686, followed by R Hydrae in 1704, discovered by G.D. Maraldi. Progress in these early years was remarkably slow. By 1786, astronomers had identified only 10 variable stars in total, a number that seems astonishingly small compared to today's catalogs. These early discoveries were made primarily through naked-eye observations or with rudimentary telescopes, requiring extraordinary patience and meticulous record-keeping. The limited pace of discovery during this period reflected both technological constraints and the prevailing astronomical interests of the time. Variable stars were considered curiosities rather than central objects of study, and their scientific importance was not yet fully appreciated. Nevertheless, these early observations laid the crucial groundwork for future investigations by establishing that stellar brightness could indeed change over time, a fundamental concept that would later become central to our understanding of stellar physics and evolution. The 19th century witnessed a significant acceleration in variable star research, driven by improvements in telescopic technology, more systematic observational approaches, and growing scientific interest in stellar phenomena. Astronomers began to classify different types of variable stars based on their light curve patterns, periodicities, and other characteristics. This era saw the identification of key variable star types that would later prove crucial to astronomical distance measurements and cosmological understanding. The development of stellar spectroscopy in the latter half of the century further enhanced astronomers' ability to study the physical properties of variable stars, revealing information about their temperature, composition, and motion. The period also marked a transition from individual discoveries to more organized approaches to variable star observation. Astronomers began to establish dedicated observing programs and started collaborating internationally to monitor variables over extended periods. These efforts required standardized magnitude scales and observational protocols, which gradually emerged through professional consensus. The systematic recording of observations in astronomical journals and the compilation of the first specialized catalogs of variable stars helped consolidate knowledge and facilitated the recognition of patterns across different variable star classes. Despite these advances, the total number of known variable stars remained relatively modest by modern standards. with catalogs listing perhaps a few hundred objects by the end of the century. As the 19th century drew to a close, the groundwork was being laid for the revolutionary discoveries that would follow in the early 20th century. The dedication of both professional and amateur astronomers to the painstaking work of monitoring variable stars night after night created an invaluable historical record that would later enable crucial scientific breakthroughs. This era represented the transition from discovery to systematic study, setting the stage for variable stars to become one of astronomy's most powerful investigative tools. The early 20th century witnessed a pivotal development in variable star research with the establishment of formal organizations dedicated to coordinating observations. In 1911, the American Association of Variable Star Observers, AVSO, was founded, creating a structured framework for amateur astronomers to contribute meaningful scientific data. This organization would go on to become the world's largest dedicated to variable star research, ultimately collecting over 17 million variable star observations from thousands of contributors across more than 55 countries. The AAVSO exemplified a new model of astronomical research that productively bridged the professional-amateur divide, demonstrating that carefully trained amateur observers could provide data of sufficient quality to support professional research. The early 20th century also saw the revolutionary application of variable stars to cosmological questions. Henrietta Swan Leavitt's discovery of the period luminosity relationship in Cepheid variables in 1908 provided astronomers with the first reliable standard candle for measuring cosmic distances. This relationship was instrumental in Edwin Hubble's groundbreaking work in the 1920s that proved the existence of galaxies beyond our own, fundamentally transforming our understanding of the universe's scale. The scientific importance of variable stars was now firmly established, as they had provided the key to resolving one of astronomy's most fundamental questions. Across the Atlantic, similar organizational efforts emerged in subsequent decades. The variable star section of what would later become the Society for Popular Astronomy was founded in 1961, initially focusing on 6 suspected variable stars before expanding to better established targets. These organized efforts created systematic observational programs, standardized methodologies, and reliable repositories for data that significantly accelerated the pace of discovery and analysis in variable star astronomy. The latter half of the 20th century and the early 21st century have witnessed an exponential increase in both the number of known variable stars and our understanding of their astrophysical significance. The pace of discovery has been staggering. While only 10 variable stars were known by 1786, this number had grown to approximately 46,000 by 2008, exceeded 150,000 by 2019, and reached an estimated 2 million by 2020. This dramatic expansion has been driven by technological advances, including automated sky surveys, space-based observatories, and sophisticated computational techniques for data analysis. Modern digital detectors have replaced visual observations and photographic plates, allowing for the detection of much smaller brightness variations and enabling the discovery of entirely new classes of variable stars. A landmark development in variable star research came in 2005 with the creation of the International Variable Star Index, VSX, by Christopher L. Watson of the AAVSO. This comprehensive database was designed to compile up-to-date information on as many individual variable stars as possible, serving as both a repository and research tool. By 2019, the VSX had achieved a remarkable milestone, containing detailed data on 1,391,103 variable stars. The database includes essential information such as variability type, stellar spectral characteristics, periodicity, bibliographic references, and finding charts, drawing from numerous star catalogs and survey missions, including WISE, CoRoT, Kepler, K2, ASAS-SN, and OGIL. The modern era has also seen the classification system for variable stars grow increasingly sophisticated, reflecting our deeper understanding of the physical mechanisms causing stellar variability. Stars are now broadly categorized as either intrinsic variables, those whose luminosity actually changes through physical processes like pulsation or eruption, or extrinsic variables, those whose apparent brightness changes due to external factors like eclipses or rotation. Within these categories, numerous subtypes have been identified based on distinctive light curve patterns, periodicities, spectral characteristics, and underlying physical mechanisms. This refined classification system has proved invaluable for linking observational phenomena to theoretical models of stellar structure and evolution. The study of variable stars continues to yield crucial insights across multiple domains of astrophysics. These stellar laboratories provide abundant data about fundamental stellar properties including mass, radius, luminosity, temperature, internal and external structure, composition, and evolutionary pathways. The period luminosity relationships exhibited by certain classes of variable stars, particularly Cepheids and RR Lyrae stars, remain essential tools for establishing the cosmic distance ladder, calibrating other distance indicators, and refining measurements of the Hubble constant. Variable star research exemplifies the productive synergy between professional and amateur astronomy that has characterized the field throughout its history. While space-based observatories and large-scale surveys now dominate the discovery process, amateur astronomers continue to make valuable contributions, particularly in long-term monitoring of individual stars. Organizations like the AAVSO provide crucial infrastructure for coordinating these efforts, ensuring standardized data collection, and making observations available to researchers worldwide through open-access databases. The accessibility of variable star observation to astronomers with modest equipment has made this field an important entry point for citizen science participation in astronomical research. The history of variable star research traces a remarkable scientific journey spanning more than 4 centuries. From the initial discovery of Mira in 1638 that challenged Aristotelian cosmology, to today's sophisticated catalogs containing millions of stars, this field has consistently expanded our understanding of the universe and its constituent objects. The evolution of variable star research illustrates broader patterns in astronomical progress. The movement from isolated observations to systematic surveys, the development of increasingly sophisticated classification schemes reflecting deeper theoretical understanding, and the productive collaboration between professional and amateur communities. As astronomy enters the era of multi-messenger observations and exoplanet studies, variable star research continues to evolve and maintain its relevance. The meticulous observations gathered by generations of astronomers have created an invaluable historical record of stellar behavior spanning centuries, a unique dataset that continues to inform our understanding of stellar evolution and cosmic processes. The study of variable stars remains a vibrant field that connects the earliest telescopic observations to the most advanced contemporary astrophysics, demonstrating both the cumulative nature of scientific knowledge and the enduring value of patient, systematic observation of the night sky.